Algebra 1, Chapter 1, Section 6, Relations. So, relations are all about equations with two variables. At the end of the last section, Section 5, there was a relationship we had about the cost of renting movies, getting them delivered, and then going into the store and getting individual ones, and the total cost that someone would spend in a month based on that. So that's a relationship between these two things: how many movies they rent and how much money they spend. Um, when we're investigating relationships, this one's pretty basic. There are many more very complex relationships out there, and sometimes it's easier to understand them when we have different ways of relating or visualizing these relationships. Um, you can see in the on the page in the video that here are like the four most common ways, other than equations. So there's 5 ways in total that we commonly use to look at relationships. The equation is just very mathematical in it all. The other ones are visual in some way. Uh, Ordered pairs, they're just a bunch of ordered pairs like you would have on a coordinate plane. Remember, it's always x comma y when you're putting it on an ordered plane. Though, for example, in this problem here, it would be m comma capital C would be your ordered pair. We'll talk about that more in a little bit, but generally speaking, we talk it generically, x comma y, because that's what we would do when we were going to graph it. The table is ordered the same kind of way. You can see once I even put the x comma y above the ordered pairs there, that almost looks exactly the same as this table, right? X, Y, 1, 2, -2, 4, 0, -3. So all of that stuff is almost exactly the same there. It's just how we do it. Usually the ordered pairs are in a set. We would see it something like 1 comma 2 comma -2 comma 4. Ooh, that looks like a 3 there. I want that to be a 2. Comma 0 -3. And you'd have that in a big set notation. Kind of like a replacement set, but instead of just one variable being represented in the replacement set, it'd be both variables represented. So that's pretty much how we see ordered pairs written out on the page. Graph is just their physical location in space, relationship to each other. Remember, the horizontal axis is your x-axis, and the vertical axis is your y-axis. Where they meet is 0, comma 0. Going up is positive and going right is positive, which means going down is negative and going left is negative. So you can see here -2, comma 4. -2 in the x direction is here, so it goes -2 in the x, and then it goes up +4 in the y direction, and that's where your point value is. Mapping is probably kind of a new one. Basically, it's showing all the ordered pairs and how they relate to each other. 1 goes to 2, so it has an arrow from the domain, where all the x values are inputs, to the range, 2. So 1 goes to 2, and you draw an arrow between it. Now, this is a pretty basic mapping that we have here. There are more complex mappings that we'll do, but for right now, that's basically it. Sometimes you might have a little extra arrow in there, or one arrow will go to 2 spots, something like that. But that's how it is. What this is really good at is really recognizing that the domain is the x-coordinate and the range is the y-coordinate. Or if you're talking about something with different inputs, like the cost and the number of movies you rent, for that case, m would be the domain, how many movies they buy, and cost would be the range. We'll talk more about domain and range in a second, but that's the way that ordered pairs always go, is domain, comma, range. So domain, comma, range. That's how an ordered pair always works. All right, so that's the kind of the ideas of all these different relationships here. Let's actually draw some out. So you can see here in this example, they have a relationship that we're supposed to express as a table, a graph, and a mapping. It's given to us in ordered pairs. Specifically, in a set of ordered pairs. Remember I said ordered pairs usually come out looking like a set? What that means is we're going to have all four of the different examples of relationships here, but it has to give us one of them as somewhere to start. Hopefully remember that X and Y is the order in an ordered pair, and that makes making the table pretty easy. X and Y, X on the left side, Y on the right side. So 2 and 5 are paired together. -2 and 3 are paired together. 5 and -2. And the last one is -1 and -2. And there we have the table representation of that relationship. Now for a graph, you've probably done some of these before. Yeah, that's going to work. Let me adjust that a little bit. There we go. Label the horizontal axis as X, the vertical axis is Y, and I have a nice graph paper here, and if you don't have graph paper, I highly recommend you get some. And 1, 2, 3, 4, 5. I'm going to kind of label the number line to make my counting easier. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Remember, if you go down in the Y, it's negative. 1, 2, 3, 4, 5. Or if you go left in the X, it is negative. So, now let's take all of those ordered pairs and plug them in, and I'm going to put them all in red. I count over on the number line. It's not picking up my mouse really on this. I'm going to count over 2 on the X. So you can see here I got 1, 2, and go up 1, 2, 3, 4, 5. And there is my point, 2, 5. And now I'm going to do the next point, -2 in the X, so I'm going to go left 2, and then up 3. -2, 3. +5 on the X, -2 in the Y. Now, this is a very common problem here because it was right underneath the 5 there. Sometimes people would end up putting it down below because they miss that there was an intersection right here on the underneath the 5, so they don't count it. Remember, you can also always count over from the axis itself. All right. And last point, -1, -2, -1, -2, and there is my graph of the relationship. The last one is the mapping. Now for me, I don't have the nice round boxes to make, so I'm just going to make square boxes, but traditionally they use round boxes. It doesn't really matter all that much. So what I got to think about now is what goes in the domain and what goes in the range. If you remember, the X values go in the domain. And since I have that table there, that's really easy for me to look at. 2, -2, 5, and -1. Sometimes people like to order them up in order. If you wanted to do that, you just have to take a look at the table. Well, -2 is the lowest one, then -1, then +2, then +5. And for the range, it's going to be all the Y values. We got -2, but that one happens twice, and I only have to write it down once. 3 and 5. Now let's draw my arrows. -2, that's the second order pair here, goes to 3. So I'm going to draw an arrow over to 3. -1, that's my last order pair here, goes to -2. So I'm going to draw it over to -2. And then I have 2 goes to 5. 2 goes to 5, so that goes straight across. And the last point, 5, goes to -2. So 5 goes all the way up and points at the -2 at the top. So it really depends on you on whether you want all the arrows to go straight across, like it did in the example, or do you want all the numbers to be in order? It's your choice on how you do it. I'll be able to read it either way. It's just whatever one makes the most sense in your brain. Domain and range of the relationship. Last bit of the example here. Well, thankfully we did the mapping and we remember that the x values were all the domain and the y values were the range. So the domain, I'm just going to write it in a set, and I'm going to write the numbers, -2, -1, 2, and 5. And it should be in order in the domain. And same thing for the range, you're going to want to write them in order. -2, 3, and 5. And there is my domain and range of the relationship.